Now that we have a divisibility block, let's see if we can generate prime numbers. So I'm going to make another predicate block. I'm going to right click to say make a block. I'm going to make it operators. I'm going to make it a predicate so it returns true or false. I'm going to call it is prime. Now is prime only needs to take in one argument or one parameter. So if I right click, if I regular click over here on the left side, I can call this number num. And what I can do is I can go ahead and loop over a bunch of different values, test whether they're divisible. And if this number turns out it's only divisible by 1 in itself, that is the definition of a prime number. So I'm going to go ahead and grab this for loop under control. And what I want to do is when looping through these numbers, again, I'm going to start with the number 2. And let me talk about the endpoint in a second, but what I'm going to do inside of there is I'm going to grab an if statement and I'm going to test divisibility. So I can actually drag in is divisible by right here. And we can say if our number called num is divisible by all these different numbers called I that we're going to loop through, if it ever catches divisibility, if num is ever divisible by I, then it's going to report false. And the idea behind that is if you ever find that this number called num is divisible by any whole number, it's not prime. We're not starting with 1, we're not counting the number itself, so we're just going to say report false. If it catches any divisibility, it's just going to go ahead and break out of the loop, it's going to break out of this procedure entirely, and it's going to just say false, this is not prime. Now if it loops through all these numbers and it never finds anything that's divisible, let's kind of default it to report true. So I'm going to duplicate this report block. I'm going to put it at the very, attach it to the bottom and report true. Let's talk about the upper bound for testing for divisibility. For any given number, it's adequate, it's sufficient enough to loop up till the square root of that number. There's a good mathematical explanation for that. I'm not sure if I want to get into it right now, but let's go to the square root of num. Basically, that's going to cover all of our bases. It's going to cover all of our factors. If it loops from 2 all the way up to the square root of this number, and it never finds that that number is divisible by any of those other numbers, it's going to say it's not a prime number. Otherwise, it's going to report that it is prime. Let's see if that works. And to see if it works, let's actually do this. Let's actually go to control. And let me make a trigger like when spacebar is pressed. Let's see if we can generate prime numbers. So once again, let me use a for loop and start with the number 2 because 1 is not prime nor composite. And of course, 0 is not prime nor composite. So I'm going to start with 2. And I can loop however high I want to. So let's go to like, let's just say 1,000. And let's put an if statement in here. We'll say if this number I is prime. So we can drag that there. Then let's go to looks and we'll just grab a say block and we'll say the name of that number I. So this should spit out a bunch of prime numbers when I press the space key. Let's see what happens. I'm seeing 3, 5, 7, 11. It looks like it's working. I probably shouldn't have said to say it for 2 seconds because that's kind of a long time. But there we go. We have just built a basic prime number generator in Snap.